Day 576 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1590. Make sum divisible by P. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given an array of positive integers nums, remove the smallest subarray, possibly empty, such that the sum of the remaining elements is divisible by p. It is not allowed to remove the whole array. Return the length of the smallest subarray that you need to remove, or -1 if it is impossible. A subarray is defined as a contiguous block of elements in the array. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples anyway, just to make sure that we are doing this problem correctly. So, in example 1, we have our input nums equals an array of integers 3, 1, 4, and 2, p equals 6. The output is 1. Explanation says the sum of the elements in nums is 10, which is not divisible by 6. We can remove the subarray of 4, and the sum of the remaining elements is 6, which is divisible by 6. So let's break this down one step further, right? So we got this array. We want to remove elements or subarrays of this array so that after removing the elements, the remaining elements have a sum that is divisible by p. And then we want to count the number of elements that we removed, or the elements that were in the subarray. So in this case, we remove this 4. This subarray only has a length of 1 because it's only this 1 4, so that's why we return 1, right? After we remove this 4, we have 3 plus 1 is 4, and 4 plus 2 would be 6, which is divisible by p, which is 6, right? 6 divided by 6 will give us 1. But that's how we got it, right? We just removed this 4. The length of this subarray is 1, so we return 1. After removing this 4, we would be left with the 3, 1, and 2, which has a sum of 6, and yada, yada, yada. That's how example 1 works. Now let's take a look at example 2. So in example 2, the input nums equals an array of integers 6, 3, 5, 2. This time p equals 9. The output is 2. The output is 2 because there are 2 elements we remove. So let's look at them, or the subarray has a length of 2 elements. So let's look at the explanation to see what those elements are. So it says we cannot remove a single element to get a sum divisible by 5. The best way is to remove the subarray 5, 2, leaving us with 6 and 3, which has a sum of 9. So this time we're going to remove this subarray right here. Remember, a subarray is defined as a contiguous block, meaning the numbers or elements have to be already lined up next to each other. In this case, 5 and 2 is contiguous. They're already lined up next to each other. And after we remove those, we'll be left with 6 and 3. When we add 6 plus 3, that equals 9. 9 divided by 9 is 1, meaning 9 is divisible by 9. And the length of the subarray we removed was 2, right? We removed this 5 and 2. That's 2 numbers. So the output is 2. Now let's take a look at example 3. So in example 3, we have our input nums equals an array of integers 1, 2, and 3. This time p equals 3. The output is 0 because we did not have to remove anything. It says here the sum is 6, which is already divisible by 3. Thus, we do not need to remove anything. So as you can see, 1 plus 2 is 3. 3 plus 3 is 6. 6 divided by 3 is 2 with no remainders. Since there's no remainders, that means it is divisible by 3, which is what we are looking for. And it was already divisible by 3. We remove 0 numbers, so we return 0. Now, I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. Now, the first thing we're going to do is we're going to calculate the total sum of elements in the array by saying let total equal nums dot reduce, open up the parentheses, pass in 0. Come outside of that, we're going to open up the brackets, and we are going to say $0 plus $1, just like this. Boom. Then we're going to calculate the remainder when the total sum is divided by p. So we're going to say let k equal total mod p. Boom. Then if the sum is already divisible by p, then no removal is needed. So we can say if k equals 0, then we can open up the brackets and we can just return 0 just like that. Then we're going to create a variable to store our sum. So we're going to say var sum, set that equal to 0. And then we need to store the cumulative sums and their indices. So we're going to declare a variable called remainders to indexes. Sorry, y'all. Remainders to indexes. Then we're going to say colon, that's going to be a dictionary of integers. Key is going to be an integer. Value is going to be an integer. Sorry, this should be square brackets, y'all. So key is going to be an integer. Value is going to be an integer as well. And we're going to just initialize it with a square bracket 0, colon, and a -1. Boom. Then we'll also need to store our result. So we could just come right here and we could declare a variable called res equals nums.count just to start. Now we're going to say for, open up the parentheses, index, comma, num, come outside the parentheses, in nums.enumerated. And what that's going to do is it's going to get us the index and the value or the number of that index. So in this case, it will get us index 0 and 3. So 0 will be stored in index and 3 will be stored in num, right, when we do this. And then when we come here, this would be index 1 and the number will be 1. This would be index 2, num would be 4. Then this would be index 3, num will be 2, and so on, so on. So that's what this enumerator does. It gets us the index and the value at that index. So we're going to come right there. We're going to open up the brackets, and we're going to say sum plus equals num. Come underneath that, we're going to say let reminder equal sum mod p, and that's going to calculate the remainder of the current subarray. So let's sorry, this should be remainder. Let remainder, not reminder, let remainder equal sum mod p. Boom. Now we need to calculate the other remainder needed to make the sum divisible by p. So we'll come underneath this, declare a variable called other, set that equal to, open up the parentheses, we'll say remainder. Well, actually, yes, hold on. Yeah, we'll say remainder minus k plus p. Come outside of that, we're going to say mod p. Boom. Then we need to update the result with the minimum subarray length. So we'll come underneath this, we'll say if let prefix equals remainder to indexes square bracket other. Come outside of that, open up the brackets, and we're going to update the result by saying res equals min, open up the parentheses, res comma index minus prefix. Boom. Then we're going to store the current remainder and index. Sorry, y'all. Yeah, okay, that's still a if let. Yeah, this should be a if let. Boom. Then we're going to store the current remainder and the index by coming right here and say remainder to indexes square bracket remainder. Come outside of that, we're going to set that equal to index. Boom. Then we need to ensure that the entire array is not removed. So we're going to come right here and we are going to say return res is less than nums.count. If that's true, so this is going to return a Boolean. If that's true, so we're going to say question mark, and if it's true, we're going to return res. Otherwise, we're going to say colon, and otherwise, we're going to return -1, y'all. So boom, that should be all she wrote. Wasn't too much code. Okay, we have an error. Can I find remainder to indexes in scope? So it should be an S right here. So let's run that again. See if that did the trick. And it's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see. And look at that, y'all. 27 milliseconds beats 100% of users. That's what I'm talking about. That's what I'd like to see, y'all. So before we go, make sure you get one more look at the code. That's the top part. That's the bottom part. And yeah, y'all, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.